Okay, 8.2. Represent quadratic relations in different ways. So a quadratic relation can be expressed in this form, y equals x squared plus bx plus c. Okay, and sometimes we see an a there as well. Okay, or in this form, so y equals x minus r, x minus s. Okay, for the quadratic equation in this form, the r and s, put in quotes, are the x-intercepts. Okay, so that's what we can identify just by having that equation. And now for a quadratic equation in this form, so either ax squared plus bx plus c or just in this form, okay, we can tell by the c is the y-intercept. Okay, and we can say that the roots or the solutions of a quadratic relation are the x-intercepts. So if a question is asking for the roots or the solutions, that's what it's actually talking about. Okay, so if the coefficient of the x squared term is positive, so positive, okay, the parabola opens up like a happy face, being positive. Okay, and if the coefficient of the x squared term is negative, a lot of times I just put a negative sign and I circle it, then the parabola opens down. Okay, like a sad face. So example 1, find the zeros of each quadratic relation without graphing. So how do we do this? As a recall, we are going to factor. So we are going to list the factors of 12 and then see what ones add to 8. So 1 and 12, 2 and 6, 3 and 4. So 2 and 6 add to 8. So when we factor this, we get x plus 2, x plus 6. Okay, now in order to actually solve for the zeros, what we have to do is we have to take each one of these and we have to equate it to 0. So we say, when does x plus 2 equal 0? Okay, and we also say, when does x plus 6 equal 0? And we can just bring over the r2 and bring over our 6. So x equals negative 2 and x equals negative 6. So those are our two roots or our two x-intercepts. Okay, same idea for b. We're going to find all the factors of negative 30 and we're going to see which ones add or subtract to negative 1, which is that middle term. Okay, so I ignore the negative for now. Let's go 130, 215, 310, 5, 6. Okay, and which ones have a difference of 1? Well, 5 and 6. Those are just one number apart. So in my head, I'm like, okay, which one do I have to put the negative sign on in order for it to add to a negative number? Well, like the bigger one. Okay, so our two factors are going to be x plus 5, x minus 6. And in order to find the roots, again, we take both of these factors and we equate them to 0. Bring over the 5, we get x equals negative 5. Bring over the negative 6, and we get x equals 6. Those are our two x-intercepts, or our two roots. Okay, let's do the same thing. What two numbers multiply to 8? So 1, 8, 2, 4. Which ones add to negative 9? Well, 1 and 8 add to 9. So if we put a negative on both of these, then it's going to add to negative 9. So x minus 1, x minus 8. And we're going to branch these off. X minus 1 equals 0. X minus 8 equals 0. Bring over the negative 1. We get x equals 1 is one of our roots. Bring over the negative 8. We get x equals 8, which is another one of our roots. Okay, and last one, D. negative 24. So what two numbers multiply to 24? 1, 24, 2, 12, 3, 8, and then 4 and 6. And which ones have a difference of 5? So they add or subtract to 5. Well, 3 and 8. We know that 5 is a positive number, so we're going to do 8 minus 3, because 8 minus 3 is positive 5. And we're going to put these two numbers directly in the bracket. So x minus 3 equals 0. Bring over that 3, or that negative 3. We get x equals 3. And then x plus 8 equals 0. Bring over that 8. X equals negative 8. Okay, so for these last four, the question kind of really is like, what does this even mean? So let's take a look at these graphs in Desmos. Okay, so if we open up Desmos and we actually write in this x squared plus 8x plus 12. Okay, what do zeros of negative 2 and negative 6 mean? This means that the x-intercepts are negative 6, 0, and then negative 2, 0. Okay, likewise, the exact same thing, if we put in this equation here, so we have x squared minus x minus 30, okay, the x-intercepts that we got are negative 5 and 6. So when we're looking at this graph, we get the x-intercept of negative 5 and the x-intercept of 6. That's what that means. Okay, x squared minus 9x plus 8. We get the solutions of 1 and 8. So if we were to come over here to the graph, where's our x-intercepts? 1 and 8. Okay, and then the last one, x squared plus 5x minus 24. We get 3, oh, and I didn't box this one, and negative 8. So, put that in wrong. X squared plus 5x minus 24. So we get negative 8 and 3 as our two x-intercepts. Okay, example 2. Given each quadratic relation, determine the y-intercept and if it has a max or min value. Okay, so the y-intercept is just this value here. So the y-intercept is 12. And this leading coefficient, which is 1 in our case, right? Because the x squared doesn't actually have a coefficient, so by default the coefficient's 1. Okay, this is positive a value. So since a is greater than 0, this opens up. Okay, for this one, our y-intercept is 30. And our a value is negative. So a is less than 0, so it opens down. Okay, and if we were to pull up Desmos, and you want to see what this looks like, we have x squared plus 8x plus 12, right? Opens up. And then the y-intercept is 12. Desmos is so nice because it kind of plots those points for us anyways. And then we have minus x squared plus x plus 30. So opens down clearly, and this is y-intercept. Oh, there we go, 0, 30. The y-intercept and the vertex were just so close to each other. I was clicking on the vertex. Okay. All right, number 3. Given the following parabola, can this equation be used to represent the parabola? So we're given an equation here in factored form. So I would branch these off. X minus 1 equals 0, and x plus 2 equals 0. And I would bring these over. x equals 1, x equals -2. Okay, so in this equation, this is what our x-intercepts would be. Now, let's cross-reference it. Are our zeros 1 and -2? No, our zeros here are 2 and -1. So therefore, no, because the x-intercepts are different. Okay, can this be used to represent the parabola? Well, I'm going to take a look here. So this tells us that we have a y-intercept of -2. Let's cross-reference. Yep, y-intercept is -2. Now this says that we open down. This clearly opens up, therefore no, because the graph should have a positive a value. Okay, next one. Can this be used to represent the parabola? So this is our y-intercept, but our y-intercept is not 2. So we can say no, because our y-intercept is -2, right, on the graph. And then last one. Again, this is in factored form. So let's branch off the x plus 1 equals 0, and we get x equals -1. And x minus 2 equals 0, so we get x equals 2. Going back up to the graph, that's correct. So therefore, yes, the x-intercepts are the same. Okay, last one, example 4. The curve formed by a rope bridge can be modeled by this equation here. Okay, y equals x squared minus 11x plus 10, where x is the horizontal distance in meters and y is the height in meters. Okay, so if you think here, horizontal distance in meters, and y is the height in meters. Okay, write the relation in factored form. So we have y equals x squared minus 11x plus 10. So to factor, we have to list factors of 10, 1, 10, 2, and 5. Which ones add to -11? Well, 1 and 10 do, as long as they're negative. So how we'd write this in factored form is x minus 1, x minus 10. B, what are the zeros? So let's branch these off. X minus 1 equals 0, bring that over. X equals 1 is one of our zeros. And x minus 10 equals 0, so x equals 10. So what this looks like on, say, a graph, you need to look at it visually. We have 1 and 10. And this actually opens, it opens up. So it looks like that. Now question C says, what is the horizontal distance from one end of the bridge to the other? Okay, so remember this bridge probably looks something like this. Or it looks something like this and the rope is like here, right? So if we think about going from 1 all the way to 10, we would just subtract 10 minus 1, so 9 meters from one end to the other.